Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Liver Disease Prediction System Using Machine Learning Techniques 1 Rakshith DB 2 Mrigank Srivastava 3 Ashwani Kumar 4 Gururaj SP Number Department of Computer Science and Engineering, Siddhaganga Institute of Technology, Tumkur India Abstract. In this paper we are going to discuss how to predict risk of liver disease for a person, based on the blood test. Report results of the user. In this paper, the risk of liver disease was predicted using various machine learning algorithms. The final output was predicted based on the most accurate machine learning algorithm. Based on the accurate model we designed a system which asks a person to enter the details of his/her blood test report. Then the system uses the most accurate model which is trained to predict whether a person has risk of liver disease or not. Keywords: machine learning, liver disease, confusion matrix, use case diagram, backpropagation algorithm. Introduction. With a growing trend of sedentary and lack of physical activities, diseases related to liver have become a common encounter nowadays. In rural areas the intensity is still manageable, but in urban areas, and especially metropolitan areas, the liver disease is a very common sighting nowadays. Liver diseases cause millions of deaths every year. Viral hepatitis alone causes 1.34 million deaths every year. Problems with liver patients are not easily discovered in an early stage, as it will be functioning normally even when it is partially damaged. An early diagnosis of liver problems will increase patients' survival rate. Liver failures are at high rate of risk among Indians. It is expected that by 2025 India may become the world capital for liver diseases. The widespread occurrence of liver infection in India is contributed due to desk-bound lifestyle, increased alcohol consumption and smoking. There are about 100 types of liver infections. With such alarming figures, it is necessary to have a concern towards tackling these diseases. After all, we cannot expect a developed and prosperous nation with unhealthy youths. In this project we have taken UCIILPD dataset which contains 10 variables that are age, gender, total bilirubin, direct bilirubin, total proteins, albumin, A/G ratio, SGPT, SGOT, and ALK-Phos, and contains 415 as liver disease patients and 167 as non-liver disease patients. As we got through the next parts of this paper we will explain what process has taken place for the selection of best model and building necessary system for the prediction of liver disease. The major outcomes that can be expected through this project are: increased convenience for predicting a liver disease, reduction in number of deaths due to liver diseases, more accurate diagnosis of liver disease by the doctors too. Literature survey. Naive Bayes classifiers are a family of simple probabilistic classifiers based on applying Bayes' theorem with strong, naive, independence assumptions between the features. They are among the simplest Bayesian network models, but coupled with kernel density estimation, they can achieve higher accuracy levels. Naive Bayes classifiers are highly scalable, requiring a number of parameters linear in the number of variables, features/predictors, in a learning problem. Maximum likelihood training can be done by evaluating a closed-form expression, which takes linear time, rather than by expensive iterative approximation as used for many other types of classifiers. And artificial neural networks, or neural networks, are computational algorithms. They intend to simulate the behavior of biological systems composed of neurons. ANS are computational models inspired by an animal's central nervous systems. They are capable of machine learning as well as pattern recognition. These are present as systems of interconnected neurons which can compute values from inputs. A neural network is an oriented graph. It consists of nodes which in the biological analogy represent neurons, connected by arcs. It corresponds to dendrites and synapses. Each arc is associated with a weight while at each node. To do the prediction, we need to apply the values received as input by the node and define activation function along the incoming arcs, adjusted by the weights of the arcs. And is trained based on backpropagation algorithm. Algorithm, 1 extra inning data set of size m*n2. Y labels for records in x3. W the weights for respective layers 4. L the number of layers in the neural network 1, L5. Dij, L, the error for all Lij 6. T, L, Ij0. For all Lij 7. For I equals 1 to ml feed forward, xi, w, la, l, y, I, tij, l, t, l, ij plus aj, l, dot tl plus 1 IJERT 10 is 060460 www.ijert.org 949. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 8. If J0 then Dij, L, 1 tij, L, plus W, L, Ij9. Else Dij, L, 1 tij, L, where, J, W, equals Dij, L, see KNN. The K nearest neighbors, KNN, algorithm is a simple, easy to implement supervised machine learning algorithm that can be used to solve both classification and regression problems. The KNN algorithm assumes that similar things exist in close proximity. In other words, similar things are near to each other. The KNN algorithm hinges on this assumption being true enough for the algorithm to be useful. KNN captures the idea of similarity, sometimes called distance, proximity, or closeness, with some mathematics we might have learned in our childhood calculating the distance between points on a graph. SVM support vector machine or SVM algorithm is a simple yet powerful supervised machine learning algorithm that can be used for building both regression and classification models. SVM algorithm can perform really well with both linearly separable and nonlinearly separable data sets. Even with a limited amount of data, the support vector machine algorithm does not fail to show its magic. The objective of SVM algorithm is to find a hyperplane in an n-dimensional space that distinctly classifies the data points. The dimension of the hyperplane depends upon the number of features. If the number of input features is 2, then the hyperplane is just a line. If the number of input features is 3, then the hyperplane becomes a 2D plane. In short, the hyperplane is, n1, D-plane for n features. Enables Python to be used as an alternative application development language to C++ on all supported platforms including iOS and Android. Spider Notebook Spider is an open-source cross-platform integrated development environment, IDE, for scientific programming in the Python language. Spider is extensible with first-party and third-party plugins, includes support for interactive tools for data inspection and embeds Python-specific code quality assurance and introspection instruments, such as Pflakes, Pylint, and Rope. It is available cross-platform through Anaconda, on Windows, on Mac OS through Mac ports, and on major Linux distributions. Spider uses Qt for its GUI and is designed to use either of the PyQt or PySide Python bindings. Qt-Py, a thin abstraction layer developed by the Spider project and later adopted by multiple other packages, provides the flexibility to use either backend. 3. System design. A proposed system. The system being proposed here uses concept of machine learning, and the models are first trained, then tested. Finally, the most accurate model will predict the final result. At first, the system asks you to enter your details including age, gender, total bilirubin, direct bilirubin, total proteins, albumin, A/G ratio, SGPT, SGOT, and ALK-Phos. Values of last 8 parameters mentioned here, can be known by blood test report of the user. After taking these inputs from the user, the system compares the data input with the training dataset of most accurate model and then predicts the result accordingly as risk or no risk. The system has following advantages. PyQt library. PyQt is a GUI widgets toolkit. It is a Python interface for Qt, one of the most powerful and popular cross-platform GUI library. PyQt is a blend of Python programming language and the Qt library. PyQt API is a set of modules containing a large number of classes and functions. While Qt core module contains non-GUI functionality for working with file and directory etc., Qt GUI module contains all the graphical controls. In addition, there are modules for working with XML, Qt XML, SVG, Qt SVG, and SQL, Qt SQL, etc. For this paper, we have used the PyQt version 5, which is implemented as more than 35 extension modules and 1. No medical expertise required. You don't need to have any knowledge of medical science and liver diseases to predict the liver disease using this application. All you need to do is enter the details being asked, which are already present in the blood test report. Some like age, gender are already known, and then you will get the results of prediction. To high accuracy, the system predicts the results with 100% accuracy for the dataset that we have used while creating this application. While the accuracy might be different in some cases, it will still be high enough to be trustworthy at a large scale. IJERT 10 is 060460 www.ijert.org 950. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.ijert.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 3. Immediate results. The results here are predicted within seconds of entering the details. You don't need to wait for a doctor to come, unlike in traditional method. The general workflow of the system related to creation and working the application mainly consists of the following tasks, as we can see from the use case diagram. First, the user enters the blood test details and desktop app takes it as an input and predicts the output based on trained accuracy model and displays the result to the user whether the person is at the risk of liver disease or not. Workflow diagram. It represents flow of process which we have implemented to develop the prediction system. Building and training the system. The phase is totally worked upon by developer of the system, and end user has nothing to do with it. In this phase, we split the dataset into training dataset and test dataset, and then train the models using training dataset. Testing the models. In this phase we tested the accuracy of the models with the test dataset that was formed in previous phase and the most accurate model is figured out. Entering details and prediction. In this phase, the end user comes into picture. He/she enters the details of blood test report using GUI of the application. The application then matches the details with the training dataset of the most accurate model, and then predicts final result displaying, risk or no risk on the screen. See diagrammatic representations. The diagrammatic representations of working of the system are as follows. Use case diagram. The use case diagram of the system is as follows. Fig 2, workflow diagram 4. Implementation. The data pre-processing was done using Jupyter Notebook and desktop application was implemented using Scypter IDE. The programming language which was used is Python and machine learning sklearn was used to build the model using classification algorithm like KNN SVM algorithms.The and we found that SVM was giving most accurate result. The results for all the ML models and of final completed project are shown in the following figures and tables. Fig1, use case diagram SL.No1234 ML model SVM and KNN SVM accuracy 100%, 99.9%, 70%, 55.56% table I accuracy for each model. IJERT 10 is 060460 www.ijert.org 951. This work is licensed under a Creative Commons Attribution 4.0 International License. Published by http://www.IJERT.org International Journal of Engineering Research and Technology, IJERT, ISSN, 2278-0181 Volume 10 Issue 06, June 2021 Fig 3 Correlation Matrix Fig 4, Confusion Matrix for SVM Model 6. Conclusion and future works. Diseases related to liver and heart are becoming more and more common with time. With continuous technological advancements, these are only going to increase in the future. Although people are becoming more conscious of health nowadays and are joining yoga classes, dance classes, still the sedentary lifestyle and luxuries that are continuously being introduced and enhanced, the problem is going to last long. So, in such a scenario, our project will be extremely helpful to the society. With the dataset that we used for this project, we got 100% accuracy for SVM model, and though it might be difficult to get such accuracies with very large data sets, from this project's results, one can clearly conclude that we can predict the risk of liver diseases with accuracy of 90% or more. Today almost everybody above the age of 12 years has smartphones with them, and so we can incorporate these solutions into an Android app or iOS app. Also it can be incorporated into a website, and these app and website will be highly beneficial for a large section of society. References 1 Biomarkers for Prediction of Liver Fibrosis in Patients with Chronic Alcoholic Liver Disease written by Sylvie Navo and Bruno Runyard. 2 Strategic Analysis in Prediction of Liver Disease Using Classification Algorithms written by Piyush K.R. Shukla and Binish Khan. 3 Software-based prediction of liver disease with feature selection and classification techniques written Jagdeep Singh, Sandeep Bagga, and Ranjit Kaur. 4 Liver disease prediction using SVM and naive-Bayes algorithm written by Sdhay Anand. 5 Prediction and analysis of liver diseases using data mining written Chambal Feljan, Pujakamat Fig 5 Rock curve of SVM model IJERT 10 is 060460 www.IJERT.org. This work is licensed under a Creative Commons Attribution 4.0 International License. 951, 1.